All right, everyone. So in today's lesson, we're going to take a look at simplifying radicals that include different variables in their radicand. Okay, so on the inside of our radical. All right, now in order to do that, what you're going to do is you're going to take the root of the coefficient. All right, if there is one in these two, they're both 1 because there is no coefficient here, and divide the exponent of each variable by the index. So we see here we have x to the 8th power. Now the index here we know because the square root is technically a 2. Okay, if it's not written there, you assume that it's a 2. All right, and then here x to the 9th is a cube root. The 3 is the index in this one. Okay, so for solving this one, x to the 8th. All right, we're taking the square root of that, so you're going to do 8 divided by 2, so you're going to get x to the 4th. And that's the final answer for that one. All right, and then I have x to the 9th, and again, the index is 3, so 9 divided by 3, that's going to give me x to the 3rd. Now, we're assuming that these are principal roots, so we're going to just go ahead and say that they'd be the positive roots, but we know the square root could possibly have 2, so it could be a positive or a negative answer. Whereas a index that is odd, like 3, can only be one or the other. All right, now taking a look at these examples. All right, these I added a coefficient, so we have 81 x to the 12th. So with this, we can break it apart. We're going to do the square root of 81 and the square root of x to the 12th. The square root of 81 we know is 9, and then we have x to the 12th, and then our index here we know is 2, so it's 12 divided by 2, which would be x to the 6th. Again, exponent divided by the index. All right, and in B I have 125, so we have the cube roots of 125, and then I have the cube root of x to the 15th. Cube root of 125 is 5, and the cube root of x to the 15th is 15 divided by 3, so it's going to be x to the 5th. So it's 5x to the 5th for that one. All right, let's take a look at one more type of example here. All right, so now we're taking a look at some examples where the exponents are not divisible by the index, so there's a little bit more work we got to do with these, so let's go ahead and start by breaking it apart, and you'll kind of see what I'm getting at here. We got the square root of 25, and now we have the square root of x to the 9th. Now, we know that 9 is not divisible by 2, okay, so we can't do 9 divided by 2 to get an integer or a whole number. Okay, so what I'm going to do is I'm going to count back from 9 until I can find a number that is divisible by 2. So starting from 9, obviously we can go right to 8. So we're going to go ahead and do 8. Now we're going to break that apart into the square root of x to the 8th and x to the 1st. Okay, so x to the 8th is going to be the number we're going to divide by our index, and x to the 1st is going to remain inside the radical because that one's kind of like the leftover there. These two numbers added together should give you your original. So 8 and 1 gives you 9. Okay, so the square root of 25 is going to give me 5. The square root of x to the 8th is 8 divided by, again, 2, so it would be x to the 4th. And then x to the 1st cannot be divided by our x squared, or our index of 2, not x squared. Okay, so we're going to leave that underneath the radical, x to the 1st, or just x. All right, taking a look at the next one, similar example. So we have the cube root of 8, and we have the cube root of x to the 11th. Now again, 11 cannot be divided by 3 here. Okay, so we're going to count back from 11 until I find a number that can be divided by 3. So we go from 11 to 10. 10 divided by 3, still no good. 9 divided by 3 works. Okay, so we're going to go ahead and break that apart. Okay, so I have x to the 9th. And now the leftover to get that to 11 would be x squared is the leftover. All right, now the cube root of 8 is going to give me 2. The cube root of x to the 9th, 9 divided by 3, is going to give me x to the 3rd power. And then x squared cannot be divided by 3, so it's going to be the cube root of x squared, and that's going to stay underneath my radical. All right, so there's a couple of examples of how to simplify these radical expressions that include variables.